Good morning, everyone. I think much have been talked about artificial intelligence, and I'll find education have also to be given priority because all of us, we need to learn. So my talk today will be about AI and education. And why we have thought about or why we have focused on AI and education is because there are a lot of challenges in our African universities. As you are aware, we have financial crisis, which have made most of the universities to be not to be in a position maybe to have enough teaching staff. And therefore, most of the universities have turned to electronic learning. And once they turn to electronic learning, there is a problem of having enough instructors who can support the electronic learning or the online learning. And most of the students, because in African setup, we will find rarely do we have free education. So again, most of those who are in higher educations or institutions are required to be working to sustain themselves within maybe or to sustain their higher education. And therefore, most of them have opted to go for online kind of learning, which is more efficient in terms of geographical location, in terms of time. And therefore, there's need to think about how AI can improve our e-learning systems. And we have a lot to do with the educational data mining, things to do with exploratory behavior and creativity, intelligent virtual reality tools. So these are some of the areas I'm going to speak to. So what we did is that we did a proposal on how we can have our electronic learning enhanced, and this proposal was funded by the National Research Fund. That is the organ in Kenya which funds the research, and it's given the research money by the government. So it was a kind of a multidisciplinary research because, you know, AI cuts across. You have to bring other disciplines when you want to solve problems using AI, because actually you want to solve in a specific area like in education, where we need people who have educational background. And an area I like because I am a teacher by profession. I have taught for a number of years in high school before I joined university to handle computer science. So I like education because I know the challenges which are there when you are teaching. And we are working together with University of Nairobi and also the Comparative University of Kenya. Those are the universities we are collaborating with. And the research have also funded 5 PhD students who are handling different projects in AI and education. And there are also master students who are also assisting to explore the area of machine learning in different areas of AI and education, as listed now below here. So, in order to enhance e-learning, we need to create softwares which are using artificial intelligence techniques and mostly machine learning techniques. Because most of the learning management systems which are being utilized by our institutions, like Muuro, Blackboard, Sakai, name them, all of them, you'll find little have they integrated AI techniques. And therefore, what is happening in most of the higher education setup is whereby students are left alone. They struggle to run on their own because the materials are uploaded in the learning management system. Then maybe they meet the instructor once or twice, and then they are required to do an exam. So it has always been a challenge, even by the regulatory bodies, like in the Kenya Commission for University of Education. They have always been challenging our online education. How well are we catering our students? So we must bring AI so that we have a good alternative when the human tutor is not there. And that is what is happening most of the time in our electronic learning. The human tutor is not there. So how can you replace that with artificial intelligence technique? From the pedagogical background of teaching, learning should be adaptive because learners have different needs. But if you take the case the way now electronic learning is happening, learners are left to learn the same materials throughout. Nobody is bothered to know who is a slow learner, who is an active learner. So we thought about adaptive learning environments. This is one of the projects we are carrying on adaptive learning environment. And on adaptive learning environment, we are still on early stages because this project started at the end of last year. So we have just conducted desktop research, and we have collected some primary data. And maybe from the primary data we have collected, we have found almost all over, like in Kenya, rarely do we have adaptive learning in our learning management system. Rarely do we have it there. We found in all universities, you'll find the lecturer will upload materials, and the learners are left to learn the same materials throughout. So there is no case whereby student performance is analyzed in real time. It's only going to be analyzed at the end of the semester or at the end of the term, and the students are given maybe the feedback when it is too late. So we are seeking for machine learning interventions which can analyze student performance at real time and modify the teaching pedagogies at the right time. So that once you know the student profiles, a student is a slow learner, a student maybe requires an individualized pathway. Meaning, he may not need to learn the same way like the other learner. And therefore, those who are slow learners, the system can give them more time to learn. It can personalize their learning to a certain period. And that will give us maybe an opportunity of coming up with a learning management system whereby a learner can learn a course within a week, another one can learn a course within 2 weeks, another can learn a course within a month. But right now, the semester days we have are formally structured. If it is 2 months, all students have to finish within 2 months, including the slow learners. And that makes students who are slow learners to get away in the process, and they drop out. So you find the dropout rate is so high in our e-learning setup because those who are not able to cope up with the set time, they drop out. But if you have a way of analyzing the performance of the student, you can create an individualized pathway which will fit different students at a specific time. So there are a number of machine learning techniques which now those who are doing the PhDs, the student who are doing the project, together with the master student, are going to explore the different AI techniques and compare how well they can be used to analyze student performance and bring the required intervention, change the pedagogy, that may be the learning style, change the individual pathway of learning, and provide students with different contents. So, like as you are aware, some machine learning techniques are better than others in different problems. So we have the kernel methods, which are less memory-based, which could be better to analyze a lot of data. And there are those which are memory-based, like maybe the nearest neighbors K. And those which are probabilistic, like Bayesian networks. So we need to explore all of them, and therefore we are having different master students who are trying to explore how this works in analyzing student performance, how another one can work, and later on, we shall be able to build a plugin which can work with a learning management system and provide the best analysis. The second project we are having a look on is exploratory behavior and creativity. Those who have been listening about our educational changes in our country, we are now emphasizing on competence-based curriculum, where learners can discover and learn even on their own, rather than having exam-oriented kind of a curriculum. And this is what we are calling exploratory behavior. Learners can create an open-ended kind of exploratory and be creative. But again, does our learning management system allow learners to do that? It may not give an opportunity because they are only allowed to read notes and maybe do a quiz, and that's all. So we need to have a way of creating simulations, which are again AI-based. Student can go through a simulation, discover on his own, and come up with something new. So when you provide electronic learning to learners, even those who are not good, they can discover on their own using different simulations. Mostly in science, there are things you can There's something coming up there. So we need to think about gamification also. Meaning, we can also motivate learners through a game which can allow them to learn on their own. As you know, we are in an era whereby the young people like games. You'll find every time they are in a game, when they are having their tablets or their smartphones. So what about now doing gamification in education? The learner will be more creative and come up with an idea using a game. The other project we are having a look on is educational data mining. And this is a very big area, as they know about big data. There are so many things you can do. Right now, almost all learning management system, like for example, Muuro, there is a lot of data extracted from students' learning profile. But what do you do with this data? That data is not going to be used to improve maybe the learning process. So there's a need to come up with learning analytics kind of system, also predictive analytics, and this is possible through machine learning techniques again, whereby if you analyze the data which have been stored in our learning management system, are you able to give the student feedback and how maybe well they're interacting with instructors? Because learning can only occur when intervention is done at the right time. Like you find, we have already checked in our learning management system, there are students who access the system once, but there's no intervention done. Analytics are there, how they are accessing. There are also analytics you find, the way maybe they are performing the quizzes and intervention was required. So that data is not helping the instructors at all, because they are only using it to grade the student. Once the student is graded, you forget about all the other data which was stored in the learning management system. And machine learning techniques are there. So this is a project we are also carrying out to see how machine learning techniques can bring an intervention, even for self-regulated learning, learner-centered, so that the learner can be regulated from the analytics which are there. And again, instead of going back to the same mistake which other learners maybe did, as you are aware, machine learning technique can improve by experience. It can show the learner how learning can be better done than how it was done by another learner. And therefore, it can be a kind of AI mentor. That's what I'm trying to talk about. You can bring an AI mentor from the learning analytics. And most of the students who are doing online learning, they don't know which instructor they can consult, because of they have they have specific problems. But if they have learning analytics done, it is possible to know where the problem is, who is the best tutor, who can help the learner, given the problem is of this type. And just like any other field in AI, this data mining will help us to do educational experiments. Because most of the problem we are facing, there is no empirical evidence. Like sometimes we say, students are performing poorly. Do you have any empirical evidence? And that is there. Maybe a machine learning technique can help us to know or to predict why these have been happening. And this is possible through deep learning. You can know some pattern, even for the different caches we have. If you do data mining and you check, maybe you find some students who have a given kind of a cache are always oriented to a certain problem, and they can be helped earlier when they are joining the university or they are joining the course. I mentioned about gamified learning, and it goes together with reinforcement learning. As you are aware, reinforcement learning is one of the techniques in machine learning, which also helps machine to learn. And it also helps individual or human beings to learn. As is well known, it's borrowed from the learning methods which are there in human beings. So, do we have reinforcement learning for our learners in electronic learning? That one is missing. Because most of the learners feel when they are doing electronic learning, they are left alone. There's no reinforcement. But maybe some learning which requires a lot of time to conceptualize the idea, you may use a serious game. And serious games means it is part of learning. The game has the required content for learning. Like in mathematics, where we have already done research and found most of the students do not like mathematics. Maybe if you approach with a serious game, because majority likes games. If you approach maybe a certain problem-solving technique using a serious game, you could encourage the student to like mathematics maybe in your class. And when they are learning alone, because you are talking about electronic learning, they can play a game, and at the end of the time they are finishing the game, they have learned a concept. We are trying to explore that and see how possible it is in our higher education institution kind of learning. And also, even if it's not a serious game, you can use gamification. Gamification here, it means maybe the content are not going to be learned through a game, but by playing a game, you are rewarded. So you are motivated to learn, because playing the game, there is a reward. And that happens in most of the learning situations whereby learners need to be encouraged. So when they learn with their peers, they can be doing a game. And that game will lead them to the learning process. Like use of recurrent neural networks is one way of exploring deep learning in areas of gamification. So apart from recurrent neural networks, the other algorithms we are also trying to explore and see how well they can work together with the serious games. Lastly, we have the other project we are carrying out, which is auto-generated exam system. And this one, when we did our primary data collection, it was quite encouraging, because all lecturers are saying the biggest burden they have is setting exams. Because in our setup, like in the Kenyan situation, and which happens in other African countries, we have so many exams because of so many programs. Like if I give a case in Kenya, we have students who come when others leave. Sometimes we call the continuing education program. We have what we call distant learners. And again, we have special examinations. So most of our lecturers are spending 50% of their time setting exams and marking. Now you can imagine the time left for research and teaching. The other 50%. These have shown there's a big burden on setting exams and marking. So most of the lecturers are happy with this kind of a project, and they're asking, when is this going to happen? An automated exam setting system. And we are trying to explore the idea of using natural language processing, because as you are from the educational background, we need to use theorems like Brooks' taxonomy theory in setting exams, which is a well-known theory, where you need to set a standard paper. Look how the knowledge, how you are assessing the student in terms of knowledge comprehension, in terms of the sentences of the knowledge, among other areas. So we want to come up with a way of creating a very big database. Like if you get 100 lecturers who are teaching computer science, for example, in database system, ask the lecturer maybe to set 10 questions on a topic, together with the answers. Then use natural language processing, which is the text tagging to the required Brooks taxonomy, set a standard paper. It means, as a lecturer, if you have 1,000 database of questions for a given topic, do you need really to worry where to get a question? Within a minute, we will generate an exam, which is quite standard, and give to your student. So even if you are told student you are supposed to set 10 exams for the same unit, because there are 10 different students who are doing, you will not get worried. And that has become a major issue in Africa, because most of our setup, we have mobility, a lot of mobility. Today, you have students who are distant learners, for example, in the military. Like here we have a military course. Sometimes you find when you set an exam, some students have already been sent. And you know, in the areas like military, you have to attend the job, because if you don't attend that time, there's nothing which is going to be done. You are required at that time. So you can't say, I'm doing an exam. You have to immediately to attend maybe to the job. So sometimes they force you to keep on setting exams. But if you have automated exam setting, you can tell them, tell me when you are ready, your exam will be given at that time. And there are some learners who learn very fast, who learn at a very fast rate. They finish the course before the others. If we are going to actually to bring efficiency in e-learning, we can allow a student to be doing exam when they are ready. If someone can finish a course within a month, why should he wait for 3 months? He can be given the exam after 1 month and maybe start another course. So that is something we are having a look on. And even now, automated assessment. Once it's done, can it be marked automatically? And the student can get the real-time feedback. And being the issue of unbiased grading. All these have been there in the news, which are maybe, as you have seen, there are those who talk about marks for sex. A lot of terms have been used, whereby people are biased. They give marks because of other reasons. Can we bring unbiased grading so that we don't penalize the student when he's not supposed to be penalized? And individual assessment also. Giving individual assessment means, as per the individual needs of the student, he can have a different assessment from the other student. Like that case of learners who are slow learners, maybe. You may not need to assess them the same way with another learner, so that they don't feel they are still at the low level. Because again, under ethical consideration, we should encourage students, even if they are weak. They should not be shown they can't do anything. They can have their own exam at that level where they are weak, and they feel they have done something. But the challenges we are still going through is the natural language processing. As you know, multilingual is one issue whereby different languages have to be known when maybe you are setting those exams and process the language. And also, examination policies is also an issue, because every institution has its own exam policy. So this is something we need to see how well we can align our exam policies so that it can allow automated exam settings. Because right now, most of the examination policies do not allow that kind of automated. And finally, is the future trend in AI and education. We need to focus on computer vision, whereby even you can read the student expression when they are in the class. And with that historical data, can you be able to create a pattern for future learning of your student? Because with computer vision, we can bring machine learning techniques which can capture and code classroom activities so that in the future classes, you don't repeat the same mistake. Also creating virtual classrooms where you are accommodating all people who are physically challenged. Those who are not able to hear, they have the vision problem. Can you have a machine which can be able to handle the physically challenged kind of issues? And bring the idea of AI mentors. When the tutors are not there, can we have AI mentors for our distant learners or online learners? Thank you. And in case there is a comment, because these are an ongoing research which have just started last year, I would like to welcome them. I don't know whether I can be given 5 minutes for any comment.
If there's any questions or comments, please raise up your hand and then we'll get a mic to you.
Hello. Thank you for your talk. I'm also a lecturer in London, and I'm really interested in automatic exams and in automatic assessments. So I'm very supportive. I would like to understand a little bit more of like how you think you can implement this in a way that it works for the students, but also that it works for the teachers. Can you maybe provide some details of how you would implement the automatic setting of exams and the automatic grading of exams so that it is actually easy to work with and that it is fair for the students?
Okay. Let me first of all respond to that one. I think the idea here we are trying to bring is to make sure that the source of knowledge comes from the lecturer, so that all the questions we are going to set are supposed to be provided by the instructors or the lecturers. Yeah, so that they don't feel whatever the assessment they are doing with their students is something generated by the computer. No, we want to make sure that they bring the data. They are the source of the knowledge. They create the domain from the source of the knowledge of the lecturer.
Thank you for the talk. I'm a lecturer from Zimbabwe. What I wanted to know is the data that you'll be working with. Do you have any plans to release it as a data set that other learners can actually use?
As I've said, the research is funded by the National Research Fund. So we want to create plugins which are going to work with Muuro, which is one of the open source learning management systems. So once we do the plugins, we are going to release them because, as you are aware, most of the plugins which work with Muuro are open source. So we want also to create a community of learning, the way we have a community of learning in Muuro. So we are going to have some plugins, and some of these plugins, we are going to release them for those who are working, for example, with the open source software like Muuro.
Hello, my name is Matlatse. Thank you for the presentation. I'm interested in the computer vision module that you want to put into this work regarding education. I don't think personally I'm comfortable with a camera looking at my face during the lecture. What privacy issues do you consider when you do that? And what is the main interest? Why do you want to see students' expressions?
The issue of teaching as a profession. When you see the facial expression of your student, as an instructor, there's some message which can be passed to you. And sometimes they even force you to change your teaching method. Like you find when you are teaching mathematics, there's a method you use and everyone has slept. So you wonder and you realize there's something wrong. Maybe you can even introduce maybe something like a game in the middle to make sure that the student and their sense again. So, but there are ethical issues there which have to be considered. Yeah. Thank you. I'm still around, and I think we shall keep on interacting and welcome for more comments later on. Yeah.
Okay, we're going to start the second spotlight session. Can we have the mic? We are having the second spotlight session with Indaba.
Okay, hello everyone. So today I'm going to present my paper which got accepted in KDD workshop, DCCL in Alaska. So this work is mainly led by the Home Depot and relational AI. So in this paper we propose a robust method for outlier detection and outlier removal to improve the performance for image classification. Actually, increasing the size of training data does not necessarily raise prediction accuracy, due to instances that may be poor representative of their respective class. So, four separate experiments are tested to evaluate the effectiveness of outlier removals for several classifiers. First of all, it's embedding, which is generated from a pre-trained neural network, fine-tuned neural network, as well as Siamese network. Subsequently, outlier detection is evaluated based on clustering quality and classification performance from a fully connected forward neural network, Kinner's neighbor, and a gradient boosted model. We propose a two-stage process to optimize the training data for image classification. The first stage focuses on deep neural network-based feature extraction that aims to learn low-dimensional and continuous representations so that the labels classes are separated in the embedding space. The second stage involves in detecting and removing outliers based on the embedding from the first stage. So the experiment is designed to test the efficiency of each stage for training two distinct datasets. So the embedding for fine-tuning and Siamese network were clustering using key-mean algorithms. The normalized material information NMI score was calculated for each embedding type. So the NMI score of the embedding extracted after Siamese network outperform all the other methods that we have experimented with. These differences in clustering quality are illustrated using T-SNE visualization, and we can easily see that there is a clear separation between different clusters of classes in the Siamese network-based embedding. Initially, the prediction accuracy is tested for 4 separate classification problems. Without outlier removal, where a gradient-boosted model achieved the highest accuracy with 90.7% on the product view and 87.4% on the area rag pattern dataset. For all the 4 experiments, the effect of outlier removal are evaluated. Basically, a range of 3 to 5% of the training data were removed using a DBScan algorithm. The performance improved significantly for classification leveraging embedding from a Siamese network. Accuracy of a KNN and XGBoost classifier raised by 1% and 2% on both datasets after outlier removal. This result demonstrates the importance of learning and refining the efficiency of feature representation before applying density-based outlier detection method for improving classification performance. To summarize, this work aims to answer several questions when challenging the quality of available dataset. It also demonstrates the success of introducing second-stage classifier instead on relying on a single advanced neural network model. By subsequently training Siamese network, outliers were identified more effectively, and classifier performance was raised in all cases. Thank you very much.
Hello. Hello. My name is Sam Aski. I'm from Malawi. I'm here to present on counterfeit banknote detection system. All right. So back at home, there have been several recorded cases of fake banknotes circulating and flooding the markets, right? But that is not the problem. However, the problem is people there really do not know how to identify a fake banknote from a genuine one. And this has been the case acknowledged by some of the people in the field of commerce to say, usually bank professionals don't get to identify the notes. It's usually the local traders themselves into the task. So here's just an example of a fake banknote, Malawi 2000 question note, and that is a fake one. Well, if I may ask, how many of you have actually gone to the task of looking at the Kenyan note, the one that you've been given, to see if it's actually fake or genuine? Oh, there's one there. All right, cool. So usually just look at the value that's there. For example, there's a 2,000 there, and I'm like, oh my God, that's just a 2,000 Malawian kwacha. If it's here, I see a 100, I'll be like, it's a Kenyan shilling, it's a 100 Kenyan shilling. But it's approximately 10 million fake banknotes have been detected in our flow of money just in 2 years, from 2017 to 2018. That's a really big number. And, well, this thing's not working, or good. So if this goes unchecked, and I mean, we can let everybody print the fake notes, right? There seems to be no problem, but actually it has really huge, devastating impacts on the economy. Some of them are listed here, like the loss of currency value, inflation, and whatnot. This motivated me to actually venture into the field of ML, but then there was one problem. There was no data set I could work with. So this was the problem I faced. Now, as a new practitioner in ML, I had to go into the cumbersome work of taking pictures as my recording data, training data, taking pictures. So I went into the task of using my mobile phone. I had to go take pictures of the 7 banknotes in Malawi. 7 banknotes. So the highest one is 2,000 question note. Yeah. So I took over 7,000 pictures. That got me like 3 weeks to a month. And my mom really thought I was going crazy. Like, you explain to them, I'm doing this for machine learning. To her, it sounded like I'm doing this for Really, that was the case. So each and every time I'm eating, you go to the restroom, to the toilet, and you have a chance of taking a banknote. So that was the case. But I had to use computer vision and image augmentation to generate new images of the notes. So I came out about 30,000 images, which is still not enough. So you see the kind of problems I'm trying to address here. So I had to start practicing. And by the way, it's illegal to hold, even take pictures of banknotes. By the way, especially in my country, my nation, Malawi. So I had to go through that. Currently, I used Inception V3 and MobileNet just to train on classifying the banknotes, just knowing the value. And I had to do this for over like a week, different runs. I came to points of 93% accuracy and 85 for the MobileNet. And yes, these are like the vision is to see a computer-based and a mobile app that can be up to use in identifying the notes. So the development currently, I'm having one that mobile, just a classification that can classify the banknotes under different lighting conditions and the different types of notes, whether wrinkled, dirty. So this is just for classification. I haven't gone to the real field of identifying whether it's real or fake. Okay, so that's I've learned from Aladdin, with the help of Aladdin, on CMIN's neural networks and the GANs itself. So that's what I'm going to use, and this is I'm working with the Reserve Bank of Malawi on them handing me some fake notes, samples of them I can work with. So from there, now imagine if your country, don't look at me like you don't have these problems in your country. I mean, we have them everywhere else. Yeah, thank you. So we're talking of an innocent businessman going to the bank just to find out that they've been declined. Okay? So this is the case. It might not be you today, but it will be you next time. And you really get arrested for finding with a fake banknote just for dealing with a local businessman and you're given change that is fake. Thank you very much.
Hello, everyone. I'm Samantha Phantom. We'll be speaking on predicting social unrest events in South Africa. And this is my thesis topic that I'm working with the University of Cape Town. So a good example of social unrest events are the manifestation of, well, it will be the manifestation of the followism culture in South Africa. So for example, we had hashtag Fees Must Fall, hashtag Rose Must Fall, and hashtag Zuma Must Fall. And I'm sure, like, for the South African audience, most of us were impacted by some of these protests. And I could say I shamelessly also participated in one or two of these protests. And most of these protests that I've mentioned in this example are peaceful protests, but that's not always the case. In many cases, these can become violent acts. And in South Africa, from 2004 onwards, it has social unrest activities have actually been on the incline. And what has been surfacing more are the violent protests. And violent protests protests in general have negative impacts on an economy, and as well as they can cause damage to persons and properties, and they can also pave the way for more populist policies. To be able to anticipate these events could provide a lot of benefits to the public and as well as to decision makers. So decision makers can be able to find more efficient strategies for mobilizing resources, as well as they can be able to strategize and make better policies. And in terms of the public, they'll be able to identify and be warned areas where there's high unsafety, and this will increase the safety of the public. Okay, so why anticipate? Yes, that was why I anticipate social unrest events. So how did I end up doing this? So let me talk about the data set. The data set I used is GDOT. It's the global database of events, language, and tone. This is an open source database, so it's available to everyone, and how I accessed it was via Google BigQuery. And another feature of this data set is that it is machine coded. And to me, this is actually a big factor because we don't have to do a lot of the nasty NLP processes that come with it. So we already have our features already extracted from the text data. And the text data is actually 1,000 records that have been extracted from news media articles. And the number of events that it has is up to 300 events. And most of these events pertain to conflict. And once I extracted my data, the prediction problem took the form of a time series. And the time series was then fed to an ARIMA model and an LSTM model. So ARIMA is more the traditional way in which time series forecasting has been done, and LSTMs gained recent popularity in 2017, and they have been now described as being the future of time series forecasting. And these models are actually quite opposites of each other. So the reason why, so ARIMA makes a lot of linear assumptions about your data, whereas LSTMs don't make any assumptions about your data. And as we all know that neural networks can approximate any function very well. and the data and the problem we're trying to solve is quite complex. So can we actually predict social unrest? The answer is we can predict it much better with a much lower error rate, especially if you look at the performance measures that we use, which is the mean absolute percentage error and the root mean squared error. You can see that LSTM produced significantly lower error rates to traditional approaches, and more, I think the graph actually is more encouraging, because then you can see the pattern of how the power of LSTMs in predicting this. And this was real-time predictions. So the advantage of GDELT is that it's a real-time database as well. So when you want to take this further, you can actually implement it with not having that limitation, and you can implement a live awareness system that could actually work. And to me, what I'm planning to do as the next phase for this project is to make the data more useful. So maybe adding a location feature and breaking it down per event type so it's more actionable. And you can also experiment with other methods and other architectures. One, since I've got not a lot of time left, I think the more prominent architecture is the attention model, which is actually new. And attention layer can be added to the LSTM, and this actually enhances the performance of it by being able to identify what's more important and keeping that memory within it. And you also have your CNNs. And I will be presenting this at the poster session. So if you want to get into understanding more about the methods and how I went about doing this, because it's quite a creative way that I did it in order to get those results. So it wasn't necessarily just running a time series problem. Cool. Thank you.
Hello, everyone. My name is Francis Chikweto. I'm coming from Zambia, Evelyn Hon College, and I'll be presenting my work, which we are doing with my friend Jordan from the University of Zambia, which is focused on diagnosis of cervical cancer using convolutional neural networks, deep learning. Cervical cancer is the fourth leading cancer in women. And last year, there was about 570 cases that were reported. And 90% of such cases actually occur in countries like Zambia, which are developing countries. And currently, my country is amongst the leading countries in cancer cases, cervical. And this is why we took this as a challenge, where we can use deep learning actually to try and see if it can be used for screening of cervical cancer. The reason why we have such cases that in my country, even in other developing countries, we do not have enough trained pathologists, and also the laboratories that we have are kind of limited in terms of technology. So we tried to come up with a screening tool that can be fast enough to help the fewer pathologists that we have to take decisions. So for the data sets that we used a foreign data set from the National Cancer Institute, which is, in this case, it's open access. And it has slide images, high resolution. And also, we also used our own local data set from the University Teaching Hospital, the main lab. And we collected a sample of cancerous and also normal tissue slides. And the number, you can see it on the screen. The challenge we had is that these slides are SVS files, and they are so large. So the first thing that we had to do was actually to reduce the size of the images that we have so that our model can easily read. And therefore, we from the high-resolution SVS formats that we had, the slides, we generated the 2034, 1356 pixel images, and those are the ones that we used now actually to crop them further to a smaller size, 256 by 256, and from there we did the augmentation of data so that we generate more data for our model. And the model was now ready. The images now are ready to be fed into the light DNA architecture that we used. For the results, for the best model that we came up with so far, we compared it with the VGG, which we used transfer learning to train it, and then we compared the validation data. If you look at the results, we found that VGG even took long to train, but our light model actually performed quite all right on this data set. Then for the other results, which is the confusion matrix, we wanted to see if the foreign data that we got from the National Research Institute can actually predict the cancer in the cells from our own hospital. And so the confusion matrix now, there you are able to see the results. We used the local data sets now to test our model from the University Teaching Hospital. And we found out that it was able to predict up to some accuracy. Yes, this is research is not yet complete, it's ongoing. And from the results that we have gained so far, it has potential actually to improve the cancer cases and screening processes in our country. And we are hoping that in the future, through this conference and the lectures that we are receiving a lot, we can actually come up with better models and also the architectures to help us to improve this model that we have developed. So thank you so much. We'll see you at the poster.
Everyone. I am Getenesh Tashome from Ethiopia, and my title is on bidirectional attentive matching based textual entailment recognition using deep learning. So first let's introduce what do we mean by that recognizing textual entailment. This textual entailment recognition is the task of determining the relationship between two sentences, and the relationship can be it can be an entailment, it can be a contradiction, or it can be a neutral based on the prior knowledge or the truthness of the first sentence. As you can see here, we have a premise sentence which says a white and a yellow car raced down the track, and this is our prior knowledge or the truth. Based on this, we will detect the relationship of this H1, like here, H1 with premises and H2 with premises and hypothesis 3 with premises, and detecting these classes like entailment, contradiction, and neutral will be held with this comparison. So the task is like that, and my motivation to work on this is this task called recognizing textual entailment with the other name natural language inference. It is a fundamental element for different kinds of NLP applications, higher NLP applications, like a question answering and text summarization. So to work on that, I identify with the motivation of match aggregate framework, I identify such kinds of problems on the match aggregate frameworks. This is one of match aggregate is one of the frameworks that is that's getting promising result, but it uses the attention mechanism And in the attention mechanism, it uses as a weight the cosine similarity. And the cosine similarity works like as a weight between they perform a cosine similarity between hypothesis and premises encoded sentences. And these cosine similarities will be used for a weight for the attention layer. But cosine similarities, they are good at detecting entailment and contradiction classes, but they are poor at detecting the neutral class. And another thing that I analyze is when we do the cosine similarity between two sentences, it shows the relationship between words within the two sentences. Rather, it doesn't show the relevancy score of a single word within a given sentence. So having this as a gap, I propose bidirectional attention matching with the scored weight and with the cosine and Manhattan distance matrix. So what can I first do is I encode my premises and hypotheses using BiGRU. Then I calculate the cosine and the Manhattan distance between those two matrices, and I normalized that matrix using softmax classifier. Then I used this weight for the attention. And the attention that I used here is weighted sum and weighted max attention. So I give these weights for my attention. And here, this bidirectional attentive matching will give me the premises words that are aware of hypothesis and hypothesis sentence that are aware of premises sentence. Then finally, I aggregate those two attention results using element-wise concatenation. Then I extract the shared context from the concatenated result, and I give that result for the classification, which is softmax. When I come to the experimentation and what happened? Yeah, when I come to my experimentation, I do my experiments on Amharic dataset called RTE dataset for Amharic, and I perform such kinds of experiments. You can show the results there, and here are some findings. And for more communication and for more clarification, you can meet me at poster session. Thank you for your attention.